they change from one to another. You could pause on this screen if you want to read through your learning goals. All right, if you recall from 9th through 10th grade, the 4 states of matter are solid, liquid, gas, and plasma. And if you add heat in that order, if you add heat to solid, it can turn to a liquid. Add more heat, turns to a gas. Add more heat, it turns to a plasma. And with those states of matter, it's really all about how the particles are arranged and how much energy they have and their spacing. So if we look here, the solid particles are very close to each other, almost touching. They still move, they vibrate in place, but they don't have much room to move. And that's why you can't put your arm through a solid. If you heat these up enough, they start to vibrate back and forth faster until they break apart and they have enough room now to slide past each other a little bit, which is a liquid, which is why you can move your arm through water pretty easily. If we add heat to these, they're going to move faster and faster and faster till they break apart and spread apart, and you have a gas. And it's very easy to move your arm through the air, which is a gas. If you heat up a gas enough, it becomes plasma, which is the same in terms of speed and spacing. The molecules are a little faster, but the big difference is we've stripped off electrons, creating ions, which we'll learn more about this year. All right, so the kinetic molecular theory, if you remember from 9th, 10th grade, kinetic means moving. So really this is the moving molecular theory, and it says all atoms and molecules are made up of, all matter is made up of atoms and molecules, and these are constantly in motion. The higher the temperature, the faster the motion they are. And if they're at the same temperature, well, the bigger, heavier molecules move slower than the smaller ones. The kinetic molecular theory also says the states of matter differ from each other. Like we said, the particles of a solid, they're in a fixed position. They don't move a lot, but they do move. Liquid, the particles have a little bit of freedom moving where they can slide past each other. And gas particles are always moving and just all over the place. What observations or experiments have been done to support the kinetic molecular theory? Well, diffusion in gases and liquids is a phenomenon where substances go from an area of high concentration to an area of low one. A little bit crude here, but an example would be a fart. If a person farts, it stinks really bad right by them at first, but because of diffusion, that gas spreads out, the smell spreads out to areas where it wasn't, and eventually everyone smells it, but not as strong as that initial blast. Brownian movement, we did an example of that in class if you had me for physical science. It's just the random movement of particles. So if you drop a few drops of food coloring into water, it just randomly moves and bounces off each other and eventually fills up that cup. And we did that in physical science. Go ahead, pause here while you add this to your notes. All right, so we've said the top part of all these, the states of matter here, the solids. You can read those if you want, but we're adding this bottom part and how we can change from one to another. So solids have a definite shape and definite volume, meaning the shape of a solid doesn't change on its own, and the volume, the amount of space it takes up, doesn't change on its own. Look at your computer. It's going to always be that shape unless something is done to it. And it's always going to take up the same amount of space, again, unless something is done to it. If we add some heat, these molecules in the solid will move faster and faster and faster till they slide past each other, and then they become a liquid like you see here. Liquids have a definite volume, meaning they take up the same amount of space. In other words, a gallon of water is a gallon, whether it's in a giant swimming pool, it's spilled on the floor, or it's in a gallon container. It's still the same amount, the same volume. It does not have an indefinite shape. If I asked you what the shape of water was, you couldn't tell me because it doesn't have a shape. So solid was definite volume and definite shape. Liquid was definite volume but not definite shape. And if we add heat to these molecules, they're going to move fast enough to where they spread out and they're going crazy like this molecules here. Gases don't have a definite anything. They don't have a definite shape. They don't have a definite volume. So really, if you can remember the easy one, solids, definite everything. Gases, nothing is definite. And then for liquid, you only need to remember that the volume is definite. If we add heat to a gas, it will spread out and form a plasma, like we said. And they're just like gases in that nothing is definite. Indefinite volume, indefinite shape. But that won't be on the test. Most people don't realize plasma is the most common state of matter in the universe, and it's because that's what stars are made of. On Earth, you can also see it in fire, lightning, the northern lights, things like that. Pause while you put this into your notes. All right, so phase changes when we go from one to another. like solid to a liquid. We're always going to have some heat movement. We are either going to absorb the heat or release the heat. And if we look here, solid to liquid is going from a slow-moving molecule in a solid to a fast-moving liquid. We call that melting, but to speed up from slower to faster, it needs to absorb heat. It needs to take heat in. Heat is necessary to speed those molecules up. If we do the reverse, a liquid to a solid, we're freezing, but we're going from the faster-moving molecules in a liquid to the slower solid molecules, which means we release heat. All right, liquid to gas. Liquid is slower than gas, so we're adding heat, and we call this vaporization, or common terms of those would be boiling and evaporation. Now, gases down here are faster than liquids, so we're slowing down, which means we have to release heat, and that's called condensation. This is how clouds form in the sky. And if we're going from a solid to a gas, we're going from the slowest phase to one of the fastest. It's called sublimation, but we're speeding up a lot, so we need to add heat to that. Go ahead and pause here while you put this into your notes. All right, what happens if you just keep heating and heating and heating and it goes over 1,000 degrees, up to 1,000,000, 100 million? Will everything just stay a gas? No, remember we said plasma is that highest. So solid, liquid, gas, plasma is the order. Most of the test questions will live in the solid, liquid, gas range. All right, well, we gave some definitions of evaporation, condensation, freezing, melting, but what's really happening when we do those phase changes in terms of the temperature being added? Well, we did say we have to add or release add energy or heat, which is increasing or decreasing the temperature. When we release heat energy, so like we're going from a liquid to a solid, like freezing water to make an ice cube, then the molecules slow down and get closer together because solids have slower moving and closer particles than a liquid. If we do the opposite, we go from we have an ice cube and then we melt it by adding heat. Well, heat energy is absorbed, speeds up the molecules, and they spread out because their molecules have more room to move. You can pause here if you want to review these words, but it just shows like if we start with a gas, condensation makes it a liquid, vaporization turns it back to a gas. That's how this chart works. Pause while you put this into your notes. All right, so this graph is kind of counterintuitive, meaning it doesn't make common sense. Because if you look over here, it says we're increasing the temperature. So basically, we're just constantly adding heat. If that's the case, you would think the graph would look like this. The temperature would just keep going up. But that's not the case. The temperature does go up for a while. So like if we have a solid ice cube, but then it levels off. So the big question is, what happens here and here where the graph does not get hotter even though we're adding temperature, we're adding heat to it? And the answer to that is it's breaking the intermolecular attractions. It's breaking the chemical bonds. So the attractions that hold one particle in an ice cube next to another is pretty strong, and it takes a lot of energy to overcome that. So when the graph levels off, those bonds are being broken. Once they break, bam, we have a liquid, we have water. So the water gets hotter and hotter and hotter, and then here, the bonds that are holding the water molecules together are breaking and breaking and breaking, and then finally they break and we have a gas, and at that point it just keeps getting hotter, and if it gets hot enough it would turn to plasma. So what causes those change of states? Well, we said a change in temperature, going higher or lower, freezing, melting, both ways works, or an increase or decrease in pressure, which we'll do a virtual lab to kind of refresh our memory on that. Particles overcome that intermolecular attraction. Remember, that's the flat part of the graph, the breaking the bonds. And it always involves energy, adding or removing. Add this to your notes, and then you are done. So pause it here and add it, and you're done.